Hi guys, welcome to our first start video. We've done the installation and we've set up our start file. So now it's time to turn the key, do some checks, then start the engine. We're going to go through, make sure the lambda, gears are working, make sure everything looks normal, small run through before we go to the ramp. For some of you, the ramp might be an hour away, so it pays to just make sure everything's right. There's been no problems with installation or anything like that. And we know when we get to the ramp, we can do a couple of checks and we're on our way. All right, so we've done the installation here. The communications cable's running through the umbilical. I've got it wrapped back over the back of the boat here. It's going on to my four-way Ethernet port if I want to do multi-engines, and we're plugged in. We've got M1 Tune open, so now we want to open our start file, open package. So here's our start file. We've called it starboard because if it's a single engine ECU or a single engine boat, we want to name that starboard. That second engine will be named port and so forth. So it's good to get into that habit of, naming those ECUs what they are. So double click and open, and then we're going to turn the key on, and we need to address this file to suit that ECU, because each ECU has its own individual address, and because there can be multiple engines on the CAN bus and on the Ethernet switch, we need to have each tune-up or each configuration targeted to each ECU. So let's turn the key on. All right, so I can see down the bottom here, by the way, 33713 ECU is ready. And we're going to go File, Edit Target ECU Serial Number, and then it's there ready for us. Just go OK, and then a matter of just simply sending that to the ECU. You can see we're offline at the moment, so the software sees the ECU is there, but we're going to go and now push this into the ECU. So we click the nice green arrow there, and it goes. Now, because this has actually been in there before, it went straight through. For you guys, you'll see a progress bar go across, might take maybe up to 30 seconds, 40 seconds, a few resets, and then it'll pop in, and then you'll get the situation here where we're online and it's green up the top. And you should have heard the fuel pump cycle, that's the key. All right, so we did hear that. Now we want to look at the sensors, make sure everything kind of looks normal here. So the first one I always look at is the manifold pressure, 100.2, that's right. Coolant temperature, air temperature, they all look relatively same, they're within 1 degree or less. The fuel pressure seems right, throttle position sitting in its rest of 7%, so battery voltage 12 volts, so things look okay. One last thing to look at, make sure the communications is right. Let's go check the dash and have a look and see our coolant temperature, and everything looks normal there. So let me go check. Press accept here and acknowledge our oil level. And yes, the only thing that's useful at the moment, of course, is the coolant temp, 13C. There's no errors from the diagnostics. Everything looks normal, so we're good to go. So we've got the engine in a tub of water, so we're not going to do any damage to the impeller. So the next step is to turn the key and start it up, and then we'll have a look at the next set of things. All right, so we want to check, make sure the oil pressure's okay. If it's not, the alarm would go off. All right, so we can see that there. After a couple of seconds, we should have the lambda click in. There it is. And we're looking to see eventually the closed loop will trip in. Once the closed loop won't turn on until the post-fuel compensation comes out, and then the closed loop will click on. All right, and you can see that there. All right, so that's all good. See it getting a bit leaner as we get through our post-start phase. Everything's looking okay. All right, fuel pressure still looking okay. Nothing, 14.2 down here on our voltage, so our alternator's charging. Everything's looking right. So the next thing we're going to check at is have a look across to the left here, and have we got any red statuses? No, we've got some information ones. We can click here, but there's nothing red up here. All right, so red means, no red means all good. So nothing going wrong. Back to adjust. All right, and the last thing for the minute is I want to have a look at the idle control. This is something that, because of different throttle bodies, it's an initial dial-in that we have to do with each installation, and I just want to see how much correction is happening with the idle control at the moment. So for that, we're going to go to Workspace, Engine Tuning, Idle, and Airflow. All right, and we can see here that what we're looking for here is the correction at the moment, and it's called the idle mass flow integral. So at the moment it's minus 3.5, which is pretty much what we want. If someone's put a different throttle body on it or something like that, then we would have picked that up at this point and gone, let's make a change. But for now, everything looks good. What if it's not? What do we adjust? All right, so let's go back into idle control. Idle, I've got a different setup here. Airflow. All right, here's our parameters. So normally we'd be fine tuning in our idle mass flow feed forward table here. Hopefully the shape of this table should be reasonably close. If the integral's out, if we come across now and look at the integral, it's out by, we've got a 12% correction. So that's out a reasonable way. Maybe there's a different throttle body on this particular engine. Maybe you've got the wrong start file. So if you find in general that there is a lot to correct, what you can do is come down here to the idle actuator throttle aim maximum. This is the maximum that the throttle system can use for idle control. And so in this example here we have 6, and what that means is any number in here, that the output of this table is a percentage of that 6. So if the table here is 50, then that's 50% of 6, which means it's requesting 3% throttle. All right, so if we've got a lot of error here, maybe the engine's got an air leak. If it's a significant error and you're adamant that that's the correct start file, then maybe there is a leak with the engine, an air leak. The supercharger bypass, they give problems on the hose there. But if everything is good engine-wise, then we can correct this error using kind of this scaling here. So we've got a lot of integral out, so we can correct that down. Just drop this maximum down and you'll see the integral correction coming back. Maybe I'll drop it to 5. We just want to get in the ballpark, sort of plus or minus 5%, and then we can fine tune in the mass flow feed forward main table here. All right, so as I said earlier, we're sort of looking for minus 3, minus 2, minus 4, somewhere in there. We're a lot closer there now. We're starting, the oil temperature's coming up to 40, and now we can fine tune from here across our different oil temperatures, and across some logging that you might do from now on into the future. And really just one more thing to go through before we do the trims and fuel level. Right, so I just want to run into each gear, make sure it's operating and it meets the aim. And again, that's something we'll go through at the ramp in more detail. So we're going to go forward and then neutral and then reverse and then back to neutral. Of course, I went the wrong way. I went to neutral, to reverse. So forward, neutral, reverse, back to neutral. All right, so what we're looking for now, if we go down to Mercury and gear shift, servo, I can actually at this point I can turn the engine off a little bit quieter. If I press A, that'll pause the data. And we just want a quick review here, make sure everything is working okay. We go F6. All right, and up here we've got our gear shift servo aim and our gear position sensor. All right, and we see the aim go down to 14 and our gear position sensor go to 14. Basically the two follow pretty much perfectly, which is what we're looking for, and everything worked okay. All right, so some of you might say, as before, what if it's not on the aim? You know, what if it's major? So let's just go with the scenario of being in forward gear or not reaching forward gear. So our aim here was 94 and we've got to 94, but if there's something significant, like a large error, we're talking 10% or more, there's something wrong. You shouldn't proceed at this point without fixing it. So there's really not too many possibilities. One, you could have a faulty position sensor, but if, you know, in this case, you can see it's operating okay. I can't simulate something like that happening here, so you're just gonna have to bear with me on that. But what are the possibilities? So the shift motor is damaged or weak, and it's not got enough energy to reach the gear. During the gear shift, going in, there's no cut or very little cut from our side, so there's very little effort to go into gear. So it would be unlikely that you're going to see a shift actuator fail going in. If at any time you're going to see a missed shift, that would be coming out of gear and going to neutral. All right, so I'm talking about going into either reverse or into forward, where there may be something mechanically wrong. But let's have a look at it as to what you could check from our side. So if we go to gear shift, got some channels here. The average shift time should be around 0.3, 0.4 of a second. So we've got a channel down here, gear shift time. All right, and in this case, it's complete in 0.24, and it knows it's complete because it reaches the aim. So if it's continued to try to shift and hasn't reached the aim, this shift time will be a long way up. All right, so what that means is the system's trying to push it there, and there's something mechanically wrong, some reason it can't get there. There's, from our side, from the MoTeC side, there's one other thing we can check, and that is the motor, are we driving the motor to try and reach that aim? So we go back down to gear shift, or the gear servo, sorry, and here we can see the actual duty cycle on the servo. So if we come back, I'll just scroll along. So we look where the cursor is now, we are in neutral. All right, so here's our neutral aim is 52, we're sitting at 53. All right, and then the request will come to go to drive or into forward. All right, and if we look at our shift motor output duty cycle, you can see that goes to 97. Now anything over about 50 or 60, and that's plenty of duty cycle to get it to move, and we're giving it full duty cycle to get it to move. You can see the gear position sensor moving here. It's the purple one up here, it's moving, and our gear shift motor is trying as hard as it can to reach it. As it gets closer to the aim, the duty cycle on the motor backs off. All right, and then once it reaches the aim, we recognize that as being in forward, and the duty cycle on the motor stops. So if it didn't reach that kind of 94% aim, and it got to something like 70, and the gear shift motor was putting out a duty cycle anywhere above sort of 70 or 80, it should be close to 100, then there's nothing more we can do from our side. That's something mechanical in the drive or the linkage or something's bound up. There's nothing more we can do from our side to get that to shift. All right, so again, any fine errors here, 2, 3%, that's just the tolerance between the different manufacturing of all the different gears and the whole assembly together. You can get 2 and 3% errors. Normally it's only that kind of area, and we like to, as I say, at the ramp, we'll go through after we've run it a bit more and just pop in the exact aim we want to match the mechanical throw of the actuator. All right, so that's it for the running aspect. Before we go though, we want to check that the trim works and that our fuel level lines up. So we can do that now. I don't want to get into too much detail with the trim. We've got a separate video on that I'll get you to watch, but we just want to check that it operates. So both up and down, and then it's roughly the same if you look on your dash as it was before. All right, to calibrate the trim properly, I'd suggest you watch the separate video on that, but basically there's an auto calibration where you hold it full down for 5 seconds, and we can't do that on our setup here now. So you can do that perhaps before you go to the ramp, but otherwise I think we're good to go. All right, so that's it for today. Do check out those other videos. We'll see you down at the ramp for the next one.